Hi everyone, it's Mr. Roloff here. We're going to look a little bit at some measurement and how we can actually properly read a measurement off of some of the tools that we might use here in chemistry. And we want to basically leave you feeling a little bit better than Woody here, and make sure that you're measuring correctly. So the first thing that we want to do is we want to talk about, well, why do we use the metric system? Because especially here in America, we don't typically use the metric system. If I just spit out a couple of numbers like how many inches are in a foot, that one might be pretty easy. You might say, well, I know there's 12 inches in a foot, or maybe you know that there's 16 ounces in a pint. But these numbers really aren't that easy to remember. If we look at some of these, for instance, 5,280 feet in a mile. Maybe you didn't know that. 16 ounces, in a pound. So all these numbers are really kind of abstract, I guess, if you will, compared to when you look really at our metric system. So the metric system is way easier. You don't have to memorize 12 inches in a foot, or 36 inches in a yard, 16 ounces in a pound. Everything is based off of a factor of 10. So units are really, really easy to convert, and the prefixes like this centi, you might be familiar with centimeters. Centi tells us kind of how to make the calculation. So when we're measuring, we want to be as precise as possible. And one of the key things that we need to do is we have to actually estimate this final digit. So this final digit, this is important right here. This is the one thing that most students will kind of forget to do. So basically, when we estimate that final digit, if I look at this red bar, and I'm trying to measure that red bar and see just how long it is, what I'm going to do is I can actually see with the ruler, right? I can count. We've got 1 centimeter, right? We've got 2 centimeters, and I can count 2.1. I can count 2.2. I can count 2.3. Let me just write that on here, 2.3. And then here's 2.4. So you can kind of see that it's right in between. So what I would write down, what I need to record, is I need to add this estimate, this estimation on the end. And it's basically a guess. I call it the unit of uncertainty. So what I would write down on my paper is I might write down 2.3, and it's a little bit bigger than 2.3, but it's not 2.4. So we might write, looks kind of closer to 2.3, so let's just guess. 2.34 would be an acceptable answer. You might say, well, what if I wrote 2.33? Is that wrong? No, not at all. This last unit of uncertainty is really just a guess. So there is no wrong answer. Just look at it and guess to the best of your ability. You can kind of segment that out into 10, spots in your brain, and just kind of guess. Is it like, if it's a scale of 1 to 10, maybe it's at that 3 point, or maybe it's at that 4 point. At the same time, I can't put 2.331, because now I'm saying that I'm certain of that second 3. Okay, my guess then would be the 1. Basically, this is telling me that my instrument is able to read up to this point, 2.3. I'm certain that it's at least 2.3. I'm not certain of the 3 or the 4. So if I were to write this number down, I'd be certain of this 2.33, and I'm really not sure about this guy right here, this second 3. So go ahead and hit pause on the video here. I want you to try to think about, what would you write down? So for A, when we look at A, what I can read here, this is in centimeters, is I can read the 1, right? 1 centimeter, 2 centimeters, 3 centimeters. So I know for certain it's at least 2 centimeters. It is not more than 3, right? It's under 3, but it's more than 2. So now I've got to do that guess thing. It looks like about halfway is right about here, so that's 2.5. I'm going to write 2 that's pretty close. Let's say 4 centimeters would be an accurate answer. Okay? Try on this one. Now this is a little bit more precise kind of tool to measure. We have a few more graduations on this ruler. So what am I certain of? Try B. Hopefully you tried that. Now let's take a look. It looks like I've got 2, 2.1, 2.2, 2.3. So I'm certain. I'm just going to write down that 2.3 right now. And again, here's the point that everybody misses. We've got to have that unit of uncertainty, that add-on. And it looks pretty right smack dab in the middle. I'm going to call it 2.35 centimeters. So you see, as we get a tool that's a little bit more precise, I can add more digits to how many measurements I'm actually making. So that guess, it doesn't matter what that last number is, but you should still try to make it as accurate as possible. But at the end of the day, as long as there's a number there, we'll be happy here in science. So that was measuring with a ruler. How about if we're measuring some sort of a liquid? And remember that when we're measuring in a liquid, we always want to use a graduated cylinder. We never read a measurement for volume out of a beaker. Beakers are for mixing, they're for transporting. So when I read this graduated cylinder, I'm going to read at the bottom of the meniscus. You might be familiar with that term. The meniscus is the bottom of that U. Okay, so if I were to go ahead and read this, I can read 30, and it looks like there's about 10 markings in between. So I'm going to jump right up here because I know in between 30 and 40 this is going to be 35. This is 36, and this would be 37. So I can definitely say that this is 36. And now I got to add my estimate, let's say 0.5. And we always read those in milliliters. Okay? So that would be my answer, 36.5 milliliters. Same thing over here. And this one's a little bit more difficult to read. Let's just say it looks like it's right on the 32 mark, basically. So I can read 32. But what do I do now? It's right on 32. What's my unit of estimation? Well, if it's right on there, it's not higher or lower. I still need that unit of uncertainty. Put a 0. Okay, so this would be 32.0 milliliters. And that's really the most difficult one to read because most people forget that 0.0 on the end. Go ahead and try to read this graduated cylinder. Hopefully that's enough time there. So if this is 25, it looks like it's pretty much right on the 24 mark. So if I'm certain, right, because I can read 21, 22, 23. So I'm certain that it's 24. Is it a hair above? I don't think so. So I'm going to call it 24.0. And again, we're reading volume using a graduated cylinder. So that would be milliliters. So reading the volume of a burette. A burette is very specific. It's highly graduated, and it doesn't measure how much liquid is actually in the burette. It actually measures how much has drained out of the burette. So we're actually measuring, if you imagine this, full. It started full, and then we drained it out of this burette. We drained it, and we want to know how much is gone. How much did we drain out? So what we're going to do, and here's kind of a blown up image, you'll notice that because we're measuring how much drained out, it's actually backwards, right? 28 is on top, 29 is on the bottom, which is backwards from what we were just kind of practicing. So same process applies. This is still in between 28 and 29. This is still 28.5. Down, working our way down, 28.6, 0.7, 0.8, 0.9. It looks like it's somewhere between 28.8, and 28.9. And I can be certain of those numbers. So this would be 28 point, it looks like 8. And then what's our unit of uncertainty? Oh, it looks a little bit closer to 28.9, so I'm going to call it 28.87. And again, that's another volume, liquid volume, so we're going to use the unit milliliters. Lastly, if we're taking a mass, we measure on a balance. We use electronic balances here in chemistry. And typically those are measured in grams, or if it's a really big mass, we might use kilograms. We don't need to actually add a unit of estimation. The unit of estimation is already built into the device. So electronic instruments, all we have to do, electronic instruments are nice because we just write that number down. That's our answer. There's no unit of uncertainty with an electronic measurement. Hopefully that helps understand how we actually read measurements. If you have any questions, please talk to your teacher. Thanks.